Okay, so we're looking at our foldable at linear or nonlinear. So there are several different ways you can tell if it's a linear function. First of all, if you have a graph, it can be a line, it has to be a straight line, it's non-vertical. So it cannot be a vertical line like this. That is not a function. All right, it can also be told by looking at the rate of change. It has to have a constant rate of change. That means it needs to be adding or subtracting by the same number. Okay, and it can also be rewritten if it's an equation in y equals mx plus b form. All right, so let's look at the graphs up here. So this graph right here is linear because it is a straight line that's not vertical. This graph over here is nonlinear. These are not just one straight line. This is actually the graph of an absolute value function. Okay, now let's take a look at these tables. So what we mean by a constant rate of change is that if you look at the x value, from 0 to 1, it's going up 1. 1 to 2, it's adding 1. 2 to 3, it's adding 1. All right, let's look at the y values. From 3 to 5, it adds 2. From 5 to 7, it adds 2. And 7 to 9, it adds 2. So we could say, let's write this out in our foldable, as x increases, if you look at x was going up by 1. So as x increases by 1, y is increasing by 2. That's a constant rate of change, so yes, it's linear. Now let's look at this next example. The x's are going up by 1. 1, 2, 3, 4, they're each going up by 1. Now look at the y's. Keep in mind, I said specifically they had to be adding or subtracting by the same number. So from 16 to 8, that's going down 8. It's subtracting by 8. 8 to 4 is minus 4. 4 to 2 is minus 2. Those are not the same, so it's not a constant rate of change. Now I know it's dividing by 2. 16 divided by 2 is 8. 8 divided by 2 is 4, and so on. But we said specifically adding or subtracting. So not a constant rate of change, so it is non-linear. All right, if we look at this first equation, it is y equals x plus 9. That is in y equals mx plus b form, so that is linear. If you look at this equation where it's 3x over 5, you could rewrite it as 3/5 x and then plus 0 because there's nothing out there. And so that is in y equals mx plus b form, and so that is linear. Now if you look at the second one, this x squared, that is not linear because you can't have x squared, x cubed, something like that, so that is non-linear. So things you cannot have is you can't have x squared, you can't have the square root of x, you can't have the absolute value of x, x cubed, 5 over x, x can't be on the denominator. These are all things, okay, that will cue you into non-linear. That's just a few examples there. Okay, let's go ahead and let's look at our 3.1 Day 1 notes. They are in your notes packet. All right, so does the graph represent a linear or a nonlinear function on example 1a? Okay, it is nonlinear because it is not a straight line. Does the graph on example 1b represent linear or a nonlinear function? All right, it is linear because it is a straight line that's not vertical. Let's try example 2. Let's go ahead and do 2a. So if you look at the rate of change, this is adding 3 each time. So we could say x adds 3 each time, or x increases by 3. So now if you look down here, 36 to 30 is minus 6. And so it is linear. And what statement we make is we say as x increases by 3, y decreases, because it's subtracting, so it goes down, decreases by 6. This is a constant rate of change. All right, So let's go ahead and let's see if you guys can try example 2b. So is it linear or nonlinear? Okay, so if I look at that, then I see that x goes up by 1 each time. And y is adding 2 each time. So it is linear. And my explanation would be, as x increases by 1, y increases by 2. This is a constant rate of change. All right, let's go ahead and try one more. Let's try C. So is example 2C linear or nonlinear? All right, so if you look at it, it adds 2 on each x. So now look at the y values. That's adding 7. That's adding 11. Right there, that's enough for me to say it is nonlinear because it is not a constant rate of change. Okay, let's go ahead and let's look at example 3. So which of the following equations represent linear functions? All right, and they want us to explain. So let's go through it and let's look at what we for sure know is not a linear function. So I told you guys on the foldable, it can't be x inside a square root. I said it can't be x on the bottom of a fraction like that. I said you can't have x squared. That takes out that one, and it takes out that one. Okay, so let's take a look at what we have left, and let's go through it. So y equals 3.8. All right, so if we were to graph y equals 3.8, it means everywhere, we're just going to call this 3.8. Everywhere there's an x, so if x is 1, y is 3.8. If x is 2, y is 3.8. If x is 3, y is 3.8. And so on. So that means it creates a straight line that is horizontal. So that is a linear function. We could rewrite it as if it has 0 slope, like this. So it is linear because it makes a straight line that is not vertical. Okay, this one right here is not a linear function. We should probably add that x cannot be in the exponent. So you could add that to your foldable on your list of things that are not okay. All right, this is linear because if you distribute the 6, you get y equals 6x minus 6. And that is rewritten in y equals mx plus b form. So it is linear. This one is linear. It's already in y equals mx plus b. And this one, as you remember from going over on our foldable, that can be rewritten instead of 3x over 5 as 3/5 x. And then I can put a plus 0 there. So that's also in y equals mx plus b form. So it is linear. Okay, and then down here we just have some reminders of how we can represent functions. So we can say words as a description, an equation, an input-output table. This is a vertical one. It can also go horizontal like this. This is called a mapping diagram. And then we have a graph. And those are all different ways we can represent functions.